Hey guys, Mr. Jenkins here. This will be starting the second half of Chapter 8. So we'll start with Section 8.5, which is factoring. The second half of the chapter is all about factoring, which is a big deal. You'll see it a bunch over your next couple years in math. So we're just getting started on something that's really important. So I guess just know that for whatever it's worth. So on that note, we will go ahead and get to it. So first of all, what is factoring? So factoring is, well, if we look at our problems, it says like, what is the factored form of? And then we see a quadratic trinomial. So remember back to when we took a binomial times a binomial, what did we usually get? A quadratic trinomial. So basically, you can kind of think of this almost like the Jeopardy form of that question. So this is the answer. What was the question? What binomial times what other binomial gives me x squared plus 8x plus 15? So I don't know if you guys remember a bunch of this. Well, let me show you something basic first. So all of these start with 1x squared or 1r squared or whatever. And these are the most basic ones. So anyways, we know right off the bat that our answer is going to look something like this. X plus or minus something times x plus or minus something. Now the key is, the math is trying to figure out what the something and the something else is. Anyways, so if you remember, which you probably don't, but we did a little bit of work before break where we said like what two numbers multiply to this and add to this. Okay, so this is where that comes back into play. So we're looking for here what two numbers multiply to be 15 and add to be 8. Multiply to 15 and add to 8. So remember, it's easier to start with your factors of 15. So we could have 1 with 15, but those add up with 16, and those are both positive. We're going to have positive here. 2 doesn't go into 15, 3 does. That'd be 3 and 5. And what's 3 plus 5? 3 plus 5 is 8. So that's our winner. So that these actually just finish off our binomials. So one binomial is x plus 3. The other one is x plus 5. And just like it is with normal multiplication, it would also be acceptable the other way around. So the quantity x plus 5 times the quantity x plus 3 would work as well. All right, so just moving on, I'll probably work pretty much all these today because it is, pretty important. So a difference in the next one is that our variables are, but similarity is that it's going to be r plus or minus something times r plus or minus something. And here, since you have positive, it's both going to be plus, so that's a clue that you would look for. And we're looking for what multiplies to give me 24, adds to give me 11. So we're going to look at our factors of 24. So positive 1, positive 24, but that adds to 25, positive 2, positive 12, that adds to 14, so we're getting warmer. Then we have positive 3 and positive 8. That looks like our winner. We could keep going, but we don't need to because 3 plus 8 is 11, and 3 times 8 is 24. So plus 3 and plus 8. So final answer, either r plus 3 times r plus 8 or r plus 8 times r plus 3. All right, and then the last one, I'm going to start it with x plus or minus something times x plus or minus something because x is my variable. All right, and so now what we're thinking, what's going to multiply to be 20, add to be 9. So look at our multiples of 20. 1 times 20 is 20, but when we add them, we get 21, so I need to go a little further. 2 and 10, add to 12, so getting warmer. 3 doesn't go into 20, 4 does. And that's our winner because 4 plus 5 is 9. And if you see it, guys, you don't necessarily have to list all these out. This is just kind of your mental thought process. You don't always have to show that if you don't need to. So either x plus 4 times x plus 5 or the reverse order, x plus 5 times x plus 4. All right, so moving on. As we end up with some negatives, that's where it gets a little bit tougher. So anyways, gotta kind of think about our sign rules here. All right, so nothing changes here that we get x plus or minus something times x plus or minus something. Okay, but here notice that we want to multiply to a positive, add to a negative. All right, so what type of combination would do that? A negative times a negative. A negative times a negative is a positive. Negative plus a negative is a negative, right? So looking at our factors of 24, but negative times negative. And we've already kind of done this problem. Really, this is almost the same problem as this guy up here, right? Except we're going to end up with -3 and -8. All right, so how's that look different? We say x minus 3 times x minus 8. All right, so next one, we haven't had this combination yet. Multiplies to 8, adds to 6, really -6. So let's go ahead and look at our multiples of 8. So we could have -1 and -8, but those add up to -9. We could have -2 and -4, and that's going to be our winner. -2 plus -4 is -6. So answer here is y minus 2 times y minus 4. All right, and a little bit bigger factor on the next one. X plus or minus something times x plus or minus something. And then, so what multiplies to 56? I'd say on the bigger factor ones, this is where it's good to probably list them out, but that's just me. So obviously -1, -56 would work, but that adds to -57, so we need to keep going. -2, -28, that doesn't work. That adds to -30. 3 doesn't go into 56. I think 4 does. Should have my calculator here, but that'd be, what would that be? 1, 4, so 14. So getting closer, but those add to -18. 5 doesn't go into 56. 6 doesn't. I think 7 does. -7 and -8. And those two add up to -15 as well. So that's our winning pair. X minus 7 times x minus 8. And so besides Math Excel, how could we check our answers? Remember what we're doing here, right? This is the kind of question that answers, or the answer that answers the question. So we can always multiply it out to see if it multiplies to this. So x times x is our x squared. So this would be to kind of check. So x times x is x squared. X times minus 8 is minus 8x. Minus 7 times x is minus 7x. And -7 times -8 is plus 56. When we combine our like terms, we get x squared minus 15x plus 56. So we see that it does work. All right, so again, just more problems, same thing here. This is probably the toughest one where you have a negative product, positive sum, okay? So remember here, so actually, sorry, when you have just a negative product at all, that's going to be your toughest one. So if you know you have a negative product, one's going to be a plus, one's going to be a minus. And when we add those, we're kind of thinking, which ones are, how far apart are they? We're kind of thinking about a difference here. All right, so now we're looking for factors of 15. I'll go ahead and start out with my x plus or minus something times x plus or minus something. So factors of 15, in this case, that have a difference of 2. All right, which two factors of 15 are 2 apart? So would that be 1 and 15? No, they're 14 apart. 3 and 5, yes, that's our winner, right? So now the decision is which one's positive and which one's negative. Well, if my sum is positive, then I want my larger absolute value to be the positive one, right? So it's going to be -3 and +5. Okay, so -3 and +5. So we could have x plus 5 times x minus 3, but we could not have x plus 3 times x minus 5. That would be wrong, because that would be x squared minus 2x minus 15, which is not the same thing. All right, so you can see that these are just a little bit tougher, but same thing. Next one's going to be n plus or minus something times n plus or minus something. Looking at our factors of 36, and we want the ones, the pair that are, 9 apart. Okay, so 1 and 36, those are 35 apart. 2 and 18, those are 16 apart. 3 and 12, that's our winner right there. So now the key is which is positive and which is negative. To give me a positive sum, I want the bigger absolute value to be positive. Okay, so it's -3 plus 12. So n plus 12 times n minus 3. All right, and then the last one, hard to see because of the glare. It says c squared minus 4c minus 21. So start out with c plus or minus something times c plus or minus something. Looking at factors of 21 here, and we want a pair of factors of 21 that are 4 apart. So 1 and 21, those are too far apart. 2 doesn't work, 3 and 7. So there you go. All right, so now notice here that our sum is negative, so we want the larger absolute value to be the negative one. So the 3 is the plus, the 7 is the minus. So c plus 3 times c minus 7. All right, then an application problem, a word problem. Again, hard to see on here, but you'll see it better on the notes. It says the area of a rectangle is given by the trinomial x squared minus 2x minus 35. What are the possible dimensions of the rectangle? So that's just asking us to factor, right? What times what gives me the area, right? So we're just going to factor. So it's going to be x times something times, x plus or minus something times x plus or minus something, right? Looking at our factors of 35 here. We have a negative product, so we're looking at which ones have a gap of 2. 1 and 35, that's too far apart. 3 doesn't work. 5 and 7, those have a gap of 2. If we want a negative sum, then we want the bigger one to be negative. So it's +5 and -7. Okay, so x plus 5 and x minus 7, those would be the dimensions. So I would think you could write it like that. If it doesn't accept it that way, you just say, okay, one's x plus 5, and the other one is x minus 7. All right, and then the bottom ones aren't as important, so I'll maybe just show 1 or 2 of those, not all of them. If we add that extra variable in, actually, you know what? I'll probably just skip these. I won't give you any on the homework like that, so we'll just skip that last part. I really want you to focus on the first 4 examples. Like I say, this is really important. So, people struggle with it at first. You just got to stick with it, know that it's important, and we'll be working on it a bunch. So besides that, just keep up on your homework as well as possible. And I appreciate your guys' effort. Let me know if you have questions. Thanks, guys.